All right, this is the second FRQ from the 2018 BC exam. So they give you a function that represents the density of plankton. And so for part A, they ask you to find the rate of change at h equals 25, which means a depth of 25 meters. And so we're going to say P prime of 25 is approximately, and then we've got some typing to do. So I'm going to go ahead and type this in here. Just so that I can use this and I know that I won't have any typos or anything. So 0.2 x squared e to the negative 0.0025 x squared. Okay. All right, so I've got that typed in, so I'm going to do math 8. I'm using that function I just typed in, evaluating it at 25, and I get negative 1.179. And then it wants us to interpret the meaning in the context of the problem. So before I do that, I'm going to go ahead and figure out my units. So the units of the y-coordinate, or the P of H, was the density of the plankton cells in millions of cells per cubic meter. So we're going to say millions of cells per meter cubed. And then the x-coordinate, or the h-coordinate, was the depth in meters. Okay, so we're going to say that at a depth of 25 meters, the density of the plankton was decreasing by 1.179 millions of cells per cubic meter per meter. So the per cubic meter part is talking about the density of the plankton, but the per meter here is meter of depth. So you're going 1 meter further in depth, and it's getting that much more dense as you go down. Okay. Part B says to consider a vertical column of water with a horizontal cross-section of constant area 3 square meters to the nearest million. How many plankton cells are in this column of water between h equals 0 and h equals 30? So we're going to have to do 3 multiplied by, because it says has a constant area of 3. So area of the base multiplied by the height. And so we're going to say that we have 3 times, and then it's going to be from height of 0 to 30, so 0 to 30, P of H dH. Okay, so I'm typing 3, math 9, 0 to 30, pulling that from where I saved it. 1675.415. They want the answer to the nearest million. So these are already in terms of millions, but it's a decimal. So to the nearest million is just going to be rounding. So there's our answer for part B. For part C, now they're talking about there's a function for, so you have the height from 0 to 30, then they give you another function from 30 to infinity. So anything with a depth that's more than 30, and they say that that's 105. So now they're talking about that same column of water, but they're saying that it's K meters deep. So it's deeper than 30 meters. 50 meters, 100 meters, whatever. And they want us to write an expression involving one or more integrals that gives the number of plankton cells for that entire column. So what we're going to say here is that we've got 3 times the integral from 0 to 30 P of H dH plus, and so it's got that same area of the base, which is 3. And now we're going to say 30 to infinity U of H dH. Okay, and then they said, let's do a little bit more work than that. They said, explain why that number, so this right here is the entire column. They said, explain why that has to be less than or equal to 2,000 million. And so the way that we can figure that out is we can say over here that 3 times the integral from 30 to infinity of U of H dH is 3 times 105, which is 315. And if we are to add this, so we've got 1675.415 plus 315, that's going to be less than or equal to 2,000 million. So if you were to add those together, that'd be 1990, just, slightly under. All right, so that's the answer for part C. And then part D gives us a rate of change that's horizontal, a rate of change that's vertical. That's your x prime and your y prime. And they want us to find the total distance that's traveled by that boat on the interval from 0 to 1. So I'm going to say from 0 to 1, I'm just going to use the formula. So this was from the parametric unit. And so we're going to say x prime squared plus y prime squared. And so I just need to type those in. Now you can go ahead and type it all in this way if you want. I have found that my preference, even if I'm only using it for one problem, is still to type it in to the graphing screen because I can see everything really well. The parentheses are a little bit easier to deal with here. If you were to type it in here, you'd have a lot more parentheses with the square root sign, with a sign and the parentheses there. It's just a little bit easier, I think, to type it in here and then use it from here. So 662 sine 5x 880 cos 6x. I've cleared my calculator recently, but you should make sure you're in radians because this is calculus, and so that's how we always do it. So we're going from 0 to 1, square root, first equation squared, second equation squared, $757.456, and we're done with that question.